Hey, what's up? Welcome back to another fun-filled video of differences of fractions. Ba-da-da-da-da. Fractions, they're different. What do we do? Okay, I'm really trying to keep these videos a lot more brief, so please stay on board and focus so that you have more time to kind of get things going. So, we're going to start talking about differences of fractions today. Especially when it comes to that area of compatibility, like are fractions compatible? Do they work together? Now, remember, when we're talking about differences, we are talking about the concept that we are dividing fractions. So we think about something along those lines of like, oh, if I had 5/8 and I subtracted 3/8, what would happen? That's the difference, right? And so we can think about this process of the step by step. First thing we always want to check is, are the fractions compatible? We know they're compatible if they work together, and they can only work together when adding or subtracting fractions. They only work together. They are only compatible if the denominators are the same. So if we follow this flow chart, the answer is yes, my denominators are the same. They are both 8. Therefore, I'm going to go to the next step, and I am just going to subtract 5 minus 3, which would get me 2, which makes sense because if I had something and it was cut into 8 pieces, right? And I had 1, 2, 3, 4, 5 of them, and I decided to take away 1, 2 of them. No, sorry, 3 of them. Then I'm left with 2. And that's what we're doing. It's these pieces we're taking away, right? And so now that we know that, we're just going to go ahead and have to take the denominator and convert that right back, sliding it over, keeping it at 8 pieces, because actually, look, that model says the same thing. We have 2 8s that are left over. So 5 8s minus 3 8s gives us 2 8s, right? So if that's the case that we need to do, life is good. But this isn't always the case, because when things aren't always compatible, we have to follow a new flow chart. So let's look at this scenario. I'm going to erase this real quick because this is like a lot of mess, but we saw that. All right, cool. So let's ask, oh gosh, what happens when they're not compatible? Like, what happens if I have a marker here? Hold on, I'm getting there. What happens if I have 6/10 and I'm supposed to subtract 1/2 from that? Well, there you have it. We're not compatible, and we're not compatible because these denominators are not the same. We cannot do the math with these, because think about what that, like, what does that look like? I have something and it's cut into 10 pieces, and I have 6 of them colored in. 1, 2, 3, 4, 5, 6. And now somehow I'm just subtract half of it? Like what? I don't know. What do I do? Just, nope, that's all of it. That wouldn't do any good. Let's see. All right. Like, what do we do? Could I subtract half of it by, I don't know, and just cut it in half? And this is my answer? Like, what do we do? So we have a process. Because they're not compatible, the whole goal here is we need to make them compatible. So as you can see over here, my flowchart goes to the next page. So no, my fractions are not compatible. What do we do? So we jump over here. This is our process. One, we actually need to find the lowest common multiple and convert, because what this will do is it will help our fractions become compatible, because we will be making compatible. We will be making equivalent fractions. And that's what we want. We want fractions that have the same value but look different and share the same denominator, because that's what makes them compatible. And then we go back and we can just subtract our numerators from there and then slide that denominator over. So let's look at this problem here. 6/10 minus 1/2. So there's our example, 6/10 minus 1/2. So again, they're not compatible. So the first thing I'm going to do is find the LCM. And when we talk about that least common multiple, we're talking about the multiple of the denominators. And as you learn in math, you'll actually start to understand that this is called the LCD, the least common denominator, when we do this work. So I have a 10, I have a 2, so what, 10, 20, 30, 40, I'll just stop there, 2, 4, 6, 8, 10, 12, oh, I forgot 10, this is 10, 12, 14, 16, 18, 20. Okay, so then let's see, what do they have in common? Let's see, they both share 10. They also both share 20. But if we're thinking about the least, right, the smallest multiple they share, that would be 10. So now that I've done that, this is the convert step. So I now know that I have 6/10 and I need to make it say tenths. Oh, that's easy. That means I don't have to do anything. It already does it. But now I have 1/2, and I need that to say tenths, right? So when we look down here and we look at half, well, how many times am I multiplying this 2 to get to 10? It's 1 time, 2 times, 3 times, 4 times, 5 times, right? And that's what we're doing. We're actually saying that 5 times, or 2 times 5 gets me 10. And if I'm going to multiply the denominator by 5, well, I need to multiply the numerator by 5 because, again, this doesn't change its value. It just changes how many pieces I have or with the size of the piece, because 1/2 now converts to 5/10. So again, these are equivalent. But what's cool out of this work now is that I now have 6/10 minus 5/10. Because again, remember, half just became 5/10. Now that is the case, I'm going to follow my step up here. So step 2 tells me to subtract the numerators. So I'm going to say 6 minus 5. That gets me 1. And then I just slide that denominator over because, again, I'm not subtracting the size of the piece, right? That's what the denominator says. It just says the size of the piece. The numerator says how many of them I have. So I'm subtracting the pieces. So my answer is 1/10. It's a lot of work on one page. But that's what we're doing in this case. If they're not compatible, follow the flow chart. Not compatible? Great. Find the lowest common multiple. Convert two equivalent fractions. They're now compatible. Subtract the numerators. Slide the denominator. You're done. Which also could be the same when we're using addition. But today we're just going to focus on subtraction. So let's do another one. Let's say we have 9 twelfths, and we need to subtract I don't know, what should we subtract? Let's subtract the the the, the 3/8. Sorry. This is what I get for making it up on the spot. Okay, so are they compatible? No. In fact, I already see we got some work to do in here. So they're not compatible. So if they're not compatible, right, I'm going to go back and look at my flow chart. Even all the way up here. Let's go all the way to the beginning. Are they compatible? No. Okay, let's go over here. All right, so we're going to find the least common multiple. So we're going to come back here, and I need to find the multiples of my denominators, and that is 12, and that is 8. So I'm going to go 12, 24, 36, 48. I might stop there. We'll see. 8, 16, 24, 32, 40, 48. Cool. Yeah, I'll stop there. And again, I'm looking. What do they have in common? Well, they both share 24. They both share 48. So although they have shared numbers, I want to make sure that here I'm going to take the smallest, the least common multiple, and what they share is the smallest is 24. So what that literally means, and I'm going to try to jump into that with my time here, because again, I'm trying to keep this brief, but what that means is I'm going to take 9 twelfths and I'm going to make it an equivalent fraction out of 24. Well, if I'm doing that, you can see what I'm doing is I'm literally just multiplying this by 2. There's a mathematical pattern here, and I'm going to try to model this afterwards. So if I take 9 and I multiply that by 2, that's going to give me 18s. And that's what ends up happening here is that 9 twelfths is equivalent to 18 24ths. I'm just making it 18 24ths because then it will be compatible. Okay, so that one goes to 18 24ths. Now, next I have 3/8, and 3/8 I need to convert to 24. So that's the same thing. I'm going to multiply this by 3, right? Because 8 times 3 is 24. And if I multiply this by 3, I got to multiply the numerator by 3. So 3 times 3 is 9. So 3/8 is equivalent to 9 24ths. So this becomes 9 24ths. And now I have two compatible fractions. Boy, that's ugly. Sorry, everything's kind of rammed in here. So I'm just going to read it like that. So 9 twelfths became 18 24ths. It's equivalent. It just looks different. And 3/8 became 9 24ths. And now if I do that work, I have 18 minus 9 is 9. 24 stays. It slides over. Boom. Wow. That was actually like taking half away. That's pretty impressive. Dang, that's pretty cool. I didn't even expect that to happen. Okay, so our answer out of this is 9 24ths, right? So that's the work we're doing here, right? We follow this flow chart. We say to ourselves, if a fraction is compatible, if they're compatible, yes, all right, well, just subtract the numerators, slide the denominators, life is good. But if they're not, we just have one extra step in there. What we need to do is we need to find that common multiple. We're going to use that to convert. that will give us compatible fractions because they will be equivalent. And then we go back. We'll just subtract the numerators, slide the denominators. Life is good. So with a few minutes here, I actually want to talk about why this multiplication thing happens, like why this is working, and I want to do it with a model real quick. So I'm going to focus on this 3/8 and how that became 9/24 by multiplying. So 3/8, let's do that real quick. So here's 3/8. Well, if I model that, right, that tells me I have 8 pieces and 3 of them are shaded. So 1, 2, 3, right? Okay. So what we're saying here, and we already know this, I just want you to visualize this, is that we have 9/24. So I'm going to come over here and I'm just going to rewrite that fraction so we have it. So 9/24, right? We're talking about like, how did this become equivalent? Well, remember to look at equivalent fractions, right? We can do like that copy cut count. So I'm going to do that. So I'm going to copy this model here. And again, I'm going to get, oh, that's bad. Hold on. Middle, 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 middle. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. And then we'll shade in 3 of them. 1, 2, 3. Okay. Now, again, these are 3/8, 3/8. But what we found out, what happened is we took 3/8 and we multiplied it by 3, and that got us 9/24. And if we think about that, what this denominator says is that this model had to be cut then into 24 pieces. Well, I have 1, 2, 3, 4, 5, 6, 7, 8 along here. So if I need 24 pieces, I already have 8. Well, then I need to multiply by 3 to get 24, which means if I'm going to multiply by 3, right, like we did here, that's literally me cutting this into thirds. Because if you look at that array, look what happens. There's 3 here, there's 8 here. So 3 times 8 gives me an area of 24. So there's 24 squares. Trust me on that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there's 24 squares. And then if we look at how many of them are actually shaded now, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And so you can see this is why we're just using the math, is that actually I could model this and cut this and make these things work. But also I know that with a fraction, right? If I have a fraction like 1/2 and I cut that fraction in half, right? Well, now I have 2/4. But when I cut in half, it's the same thing in fraction land as multiplying by 2. So in this case, again, I did cut this 3 times. Well, that's the same thing as multiplying it by 3 to find that equivalent fraction. So that's something to like put your mind on and think about, right? Is that we can just multiply to get the equivalent fraction. We can also draw these models to help us. And so I just wanted to end this video today with this concept of the model. Like you can actually see why it's okay that in this case, if I just find the LCM and multiply to get there, right? I'm going to end up, there you go, right here. 9 times 2 is 18, 12 times 2 is 24. That would be the exact same thing as if I drew a model of 9/12. I'm not going to draw it. And I cut it in half, I would actually end up with 18/24, or the same thing, I multiply it. Okay, so that's it. Sorry, I set my timer for 14 minutes. It already went, so I'm going to wrap this up. So there you have it. Remember, if your fractions are not compatible, then find your least common multiple, convert, make equivalent compatible fractions, then subtract the numerators, then slide the denominators, and you got the job done. You're awesome. You're the best. I'm out of here. That's it. See you in the next video. Keep rocking.